Okay, I think we can get started. Welcome for this morning session on developer talks. So I'm very happy to kick off this morning with a talk on OWL. This is kind of an experimental talk. I want to build a project in 50 minutes using OWL from the start, from the beginning. So I don't expect you to know anything about OWL. And actually, if you are an expert in OWL, you will probably find this talk quite boring, maybe. We'll see. So this is for beginners. It's better if you know some JavaScript, of course, but it is really a talk for beginners. And we will start from the beginning. I will try to explain all the most important ideas of how to work with OWL project from scratch. Okay, oh, maybe I should tell you about myself. I am Jerry. I'm working on the JavaScript framework. I've been working at Odoo for like 10 years now. And I was involved in a lot in the JavaScript code base, in the user interface, and for the last 4 years on the OWL framework. And I'm very excited to show you what it looks like now to work on the JavaScript code on Odoo. So, yeah, and I should mention that we have a pad just down there. There's this URL. Yeah, I'm sorry for those of you at the back. So this is pad.odoo.com/p/oxp-owl, and you can ask your questions. I will try to address them at the end. And of course, even if I don't, you can find me later, and we can talk about OWL if you want to. Okay, so before working on this project, I want to give you just some context on what OWL is and how it works. So OWL is a user interface, a UI component framework. If you know about React or about Vue or some other JavaScript framework, you will be familiar with OWL in a way. It's the same level of abstraction. OWL is just a way to define components which are building blocks to build your user interface. And sometimes we talk at Odoo about the JavaScript framework, and when we do that, we actually mean a little bit more than OWL. OWL is just the underlying component system, and on top of that, you have a lot of generic code in the Odoo code base, mostly located in the web add-on that give you a lot of features to build application. And that's what the rest of the business logic code is using. And then you have, on top of that, the web client application, which is really the nav bar, the main menu, a lot of features to look at the Odoo database. Okay. Okay. So that's what OWL is. It's really the underlying framework. Now, OWL is a custom-made framework for Odoo. It's class-based, so you write components as classes and not as functions. For now, most mainstream frameworks, they tend to use functions, and it's very nice. But for what we are doing with our framework, it's not what we prefer. We prefer to use class for many reasons. Yesterday, Sam made a talk on that topic, so you can look to his talk if you are interested. OWL use XML template, XML document as templates, and that's also kind of specific to Odoo, that we really enjoy working with XML documents, so we can modify them and store them in the database if needed. OWL also has modern features that you may encounter in other frameworks, such as hooks. I will talk about that, so don't worry if you don't know what a hook is. And there is a reactivity system, which means that you can write your code in a way that you just describe your state, and the user interface will pick up the change in your state in real time and apply them to the screen. So you don't need to coordinate updates to the screen. OWL will do that for you. So that's basically the main ideas behind OWL. Okay, and this is an example of what a component looks like in OWL. We have usually you have like two main parts. You have the JavaScript code and the template in QWeb language. And sometimes you have some styles, but I will not talk too much about CSS. That's really not really the topic of this talk. What I want to show you here is that we have a simple component, a counter component. So this is a component that will display a button. You can look on the template. We have some p elements which display a value, state.value, that is written in the QWeb templating language, or more precisely on an extension of QWeb, because we have additional directive. You can see this T on click. This is not standard QWeb. This is something that was added by all to specify that we want to add an event handler on this button element, and on the click event. So T on dash is the name of the directive, and what comes after click in this case is the name of the event. We can use any event. We could have T on mouse up or T on something. It would still add an event handler on that event. And then increment corresponds to the method in the component, in the JavaScript code. You see? So those are basically two facets of the same IDE. We have the implementation of a counter component, and it takes some templates and some JavaScript. I think I need to mention that we have like this state is it's using a special function, useState. I will explain that in this talk, but just for now, you can see that you can understand this function as making the state reactive. So when you increment the state and the increment method, you can see that there is no request to render the user interface. All will detect that the template read that value and will update itself, update the content of the template accordingly whenever the user clicks on that button. Okay? So this was just a short example to show you what a component looks like. Now, let's do a project together. I have a short project that you can find on this GitHub repository if you want. There is like 18 commits, and I will build incrementally. I will apply those commits in my local Odoo instance here, and we will talk about how it works, and we will do something. Now, I was thinking of an interesting project to showcase. I was thinking about making a game like Baldur's Gate 4 or something like that, but then I realized I only have 50 minutes and not 2 hours or something like that. So I decided instead to do something that I know quite well, and we will do a new web client from scratch, because basically that's my job, working on web clients. So it was fun to make it from scratch. So I will switch now many times between my browser to show you what it looks like now, and then my code editor to show you the code. So for now, this is our starting point. This is my repository, learn all in 50 minutes. And I have an Odoo add-on, which is named OXP. And inside it, we have, I don't know if it's big enough. Let's make it bigger, yeah. So we have, this is the main file for this add-on. It's really, it doesn't matter that much. I just show it so you know how our application works, but you don't need to remember anything about that. So basically, it's the main entry point for this application. We will take all templates from the proper file, and then we will take the main components that we want to mount, and we'd say that we mount our main component to the body of our page, and we give to that the templates. We give it a flag that it's in dev mode, and we give some name to our application. Let's change that. Hello, everyone. I don't know. Okay. So that's our starting point. That's just a starting point. And if you look into this is what it looks. Oh, maybe I should have shown you first the page application. The page is, for now, only a simple component, just a template that displays some text. Let's change the text. So this is just HTML for now, and I will now refresh my bind them together. And to do that, really, let's look first at the web client template. I will just scroll this down. So this is the template for my web client component, and you see there is really some HTML. This is basically HTML, and now we have something special here. We have navbar. And you can see that it's highlighted in a different color. This means that all understand this tag as a component and not as a HTML element. You see, HTML elements are all of them are lowercase, and that's the way it knows that it's a component. There is a uppercase N, and if you do that, all will understand that part of your template as a subcomponent, and it will understand that it should insert a navbar component into at this location. Now, there is something else that you need to do to do that. You need to register this navbar component as a child. The web client component may have many subcomponents. They may have different names, and at some point, all needs to reconcile the name, the navbar string that it finds in the template, to an actual class definition. It needs to know which navbar, which component it should instantiate at this location, and that's done with this object. So this static components key is really an object. This is a shorthand notation, but this is really equivalent to do this. So. Okay, so maybe it's kind of pedantic, but if you look at this, this is a string. This string is the same as this one, and then this is a value which is a component. We can see that it's a component. So let's open the navbar JS file. The navbar JS file contains an export. Don't forget to export that, and it's a class that extends component, and that's why it is a component. That's really the only way that you define a component in all. You extend the main component class, and for now it has only one template, and that's all. That's all. Just it has just one template. So it's really just a static component for now, and you can see actually so something interesting. You can see that we have some CSS or SCSS, and all of them are prefixed by the same navbar string. Now the file name is the same. So it does not matter to all that you do that, but it's a convention that we do at Odoo. So it's easy to understand where each component is on the file system. It's easy to switch from the XML to the JavaScript and back and forth. Okay, so we usually will just use the same name but with a different extension. Okay, I think it's done. Yeah. Okay, so we have now a navbar. We have a web client component. Now, for now, our web client does not do that much, of course. We will start to add a sub-application. We will do a to-do application because it's interesting to showcase some interesting properties from all. And we will do, and to do that, we will create an application here. We will replace navbar by our to-do application. So let's just do that. I will cherry pick my commit, or apply it. Now we can see what it looks like first. I'm very proud of this title. You see, this is our to-do application. I don't know why Odoo did not use that for our own application, but very proud of that. So this is a to-do application, and this is one to-do list for now that we will implement. And if you look at this, we have navbar component and to-do list. And what I want to show you is that the navbar is generic. It does not know which is the current application. And it doesn't know, it's not hard-coded in the navbar, I mean. It knows it because it was given to this component by its parent with props. This is what a props is. So let's see. I think I have the slide on that. Let me check. No, okay. I have some slides that I will come back to, but it's just later. So let's look into the code, how you can give information to a child component. And it's done with using a prop. So you see, in a template, you have a normal HTML attribute element. So the div is an HTML element. It has some attributes, class. You can have other attributes. You could have, I don't know, data, ID, something. This is an HTML attribute, but you can also add attributes to components, and then it is known under the name of props. all of those attributes are the set of props that we give to this navbar component. And in this case, you need to know that the value of this attribute is a JavaScript expression that is evaluated in the context of our web client component. Okay, so in this case, I hard-coded the string to do there, but later we will obviously do more and give it a list of applications. For now, it's just a to-do string, and that's why that's the way our navbar component can look into it. It can just look into its props object. This is the object that it received from its parent, and it will just display the value of that, which is to do. So now the navbar doesn't know what happened. Something wrong about the display. Yeah, thank you. So the props object is the set of values that a parent component gives to a child component. And it's really the main way to communicate. Now, before we go further, I want to let's remove this. I want to show you that how we can build solid application with props validation. So the fact is that our navbar component only accepts the current app props as a string, and it's only that props, and it requires it. Otherwise, it will not work. So what I did here, this is a very short commit to add those 3 lines. I added a static props object that describes the API for my navbar component, and that's really something that I think it's important. If you look into a component that you don't know anything about, you can look at its static props object, and it will describe you what this component accepts, what its external API. And once this API is valid, then it's the navbar component job to use it properly. And what if I give it, for example, a wrong prop name? Let's say that I misspell this prop. I have something else. Let's see what it looks like. It crashes, and if you look to the console, you'll see there is an error. Invalid props for the component navbar. It received CSD urent app instead of current app. So this is really this props validation object that I have here. It's really useful for two different needs. One is to document the API, the contract that your navbar component accepts, what its job is doing. So it's really nice as a documentation purpose, and it's also useful as a safety measure to make sure that your application behaves properly. So we validate that it's really like we expect. Okay. Now, I know this talk is going fast. That's because I want to go through all those 18 commits. I'm sorry, so it's going to be fast, but hopefully maybe later you'll have some good ideas in your mind, and we can talk about that. Okay, so for now, okay, yes, it's broken. I need maybe to unbreak it, yeah. Now let's now create our first to-do list component. Implement it on items. So let's do it. Now, what we have here, I created a folder to do, so I can put all my to-do components in a different location, because I think it's easier to understand what's going on when you use such a file structure. In this case, we have our to-do list component, and we have here now something new. First, we have a sub-component, which is to-do item, and then we have a list of to-dos. And maybe I should talk first about that setup function. When you write an all component, it's a class. You should not use the constructor as you probably know about JavaScript classes. They have, when you create a subclass in JavaScript, you can use the constructor. For technical reasons, you should not use that in all. You should use this setup function. This setup function is really the public constructor that you need to implement, and not the constructor that is reserved to all for its own purpose. So this setup function is our constructor, and we hardcode some data. So for now, we have just two to-do items in data. We have some ID, some description field, and some Boolean flag. Okay, and we have to-do item, which is now for now just a template basically, and there is some static props again. So we validate that it receives the data to the of the correct shape, and then we have this template where we just display those values. Let's look at the result. So for now we have web client component, a navbar component, a to-do list component which contains two to-do items. And maybe I should show you more about how we build. We have an arbitrary number of subcomponents based on those to-do items, and this is done with a T for each loop. So this is like a looping construct in a QWeb templating language. You iterate over the to-dos array. The to-dos array, if you remember, it's those values that we hard-coded here in our component. So we iterate over those to-dos. We give it a local name, a local variable name, it's a for loop. And then there is something interesting that you should not forget if you use all. You need to give a key value. This key value should be unique to this loop. It should be a string or a number, and it should be unique. And why is that? It's because all will use that key to reconcile your list whenever something changes. So whenever something changes in your list, all will render your components, your templates, I mean, and then we'll look at this list and we'll try to delete or add components or update those components accordingly. And that's why it needs this key. This is something that you may forget, but if you do, all will crash, so you won't forget for long. But if you remember, you need to add this key element. So now this template just iterates over a list of items, and you can obviously add some other items. Let's do this, and now you see I have the same ID. Let's see what will happen. It crashes again, and it says that there is a duplicate key in T for each. So it needs a unique key. Let's see. Okay, you have three elements now, 2, 3, and 4. Okay, so we're making good progress, but in our to-do list we don't see now which item is completed and which is not, and we can use dynamic attributes to do that. So let's see what it will look like. I will show you the to-do item template. So for now it's just this. So yeah, that means 5 here. Yeah. And now the only difference is that we add a TATT class attribute, and our directive is named TATT, and whatever comes after, in this case class, will be considered as a dynamic attribute, and its value will be the result of this expression that you see here. This is a JavaScript expression, and you can see that what we do here is we check for the flag is completed, and if it's completed, we just show this set of CSS class. Otherwise, this is an empty string. And the result of that is that you can see this one is crossed over, and this one is not. So that's the way it works. Okay, let me think. I think I need to go much faster. So let's move to the next step, which is adding a to-do. Now let's first see what it looks like. I can now type and add items to my to-do list. So now it's getting interactive, and that's really a good step to do that. And to do that, we had to do it the workflow to do that is really simple in a way. We create an input, and on that input we add a key up event handler. Okay. So this means that this method add to do will be called whenever we have a key up event that happens on this input. Now let's look at the add to do method. It's this one. And what it does is that it checks that it's if the key is 13, so if it's a enter key press, and if the content of the input is empty, it's not empty, and in that case it will create a new to-do item. Don't worry too much about the next ID, this ID thing. in a real application, the ID would come from the database, and so you don't need to generate it yourself. But for this short example, I just hard-coded an ID to the next ID to 4, and I increment that value. It's just for this application. Something I want to show you. What if I remove this useState function? Let's do that. Let's refresh the page, and now I will edit here, and my code is running, but it does not update the interface. And if you look into this to-do list, you can see that I have all my to-dos, they are here, but the interface is not updated. That's because OWL does not know that it should update the interface. From its point of view, there is no reason to render that component again. That's because I just removed the useState, which is really the magic that makes it reactive. Okay, now we will talk about that magic just in a moment. First I want to show you what our next task is. Our next task is to make sure that this input is auto-focused. When I refresh my page, I want to type to-do item directly. I don't want to wait for the focus. So I need to focus it. And to do that, it's actually non-trivial. And let me tell you why. Yeah, so in OWL, we have some magic functions that hook into the life cycle of a component. So if you know about React or Vue, maybe you will understand that quickly. So basically you have two kinds of hooks. You have lifecycle hooks, such as this one, onMounted. onMounted takes a callback function, and that callback will be called when your component is mounted precisely, when it is in the DOM. And it's only at this moment that the user can see it, okay? Those are lifecycle hooks. And then you have other kind of hooks, kind of magic. We have the useState hook. It is a hook. The trick to know if it's a hook, it's because it starts with use or on. Those are the two conventional name that you prefix that you use to describe a hook. Okay, so I have two kind of hooks. I'll go back to I'll talk about useState in a moment. But because they're magic, there is a specific rule that you need to understand. Those hooks can only be called in setup or in other hooks. You cannot call that hook at any moment. There is a specific moment where you can do that, so OWL can map your hook to your component. That's really the main reason. Okay, this slide may be scary, but don't worry too much. You don't need to know to remember that. You need to remember the idea. The idea is that a component has a life cycle which is quite complicated, and it's just a simplified version of it, actually. So in a real application, in a real framework, you need a lot of control on what you're doing. You need to be able to execute code at a very specific moment. And this is a simplified list of what you can do. So first you have the creation process. This is the first column corresponds to what OWL is doing to your component before it's shown to the user interface. So first it's setup, that is constructor. Then there is on will start. I don't want to explain much about that because I don't have that much time. Then you have render and mounted in DOM. Those are not hooks, those are action. The render purple square means that OWL will render only then the template. And then it will mount later, not at the same moment. That's the key part. It doesn't show that, but OWL will batch all your user interface updates in animation frame to optimize the rendering process. So because of that, the render operation will take place at just before, but there is a lapse of time, a window of time between it's rendered and it's mounted. And only then will your component be considered as mounted, and will the hook onMounted be called, okay? So that's the creation process. Then you have the set of updates. Let's not worry too much about that. So your component will can be updated many times. And maybe your component will be destroyed at some point because it has no longer any purpose. And in that case, it will first be unmounted, then will be destroyed, and then finally will be removed from the DOM. Okay? But the main takeaway from this is that you can execute code at a precise moment in the life cycle of your component, and it's very useful. And yeah, okay, this is a slide to talk about useState, but I think even if you don't understand really how OWL can make it work, it's very simple in practice to use it. You just usually describe your state, and then you update your state, and OWL will track which component read which part of the state, and will update the user interface accordingly. So that's really a magic function that most of the time do what you want, let all do what you want. Okay, so let's not talk that much about that one. Now, let's come back to our initial problem. How can we focus on input? So it seems like a very simple problem, but it's not so simple because when you are in a setup function, you don't have a HTML element. If you could have a reference to that, well, you could just call the focus method on it. There is a focus method on the input element, and you can just do that. But it does not exist yet, so you cannot call that method, of course. So first, we will need to get a reference to this input element. And to do that, it's kind of a complicated process. Each step is simple, but you need to do them, to understand them. First, we will tag we will give a name to our input element in the template. And to do that, we will use tref. Then, in the setup function, we will create a reference object that points to this element. And only when it's mounted, we will read the value from that. So let's see what it looks like. To go here. Okay, so I will cherry pick my commit. I will just validate that it works. Yeah, it's focused, perfect. And now let's see how it is done. I will open the to-do list. First the to-do list XML. And what I want to show you is we have this. This is a way to give a name to some part of your template. You could go anywhere in your template. It could be nested very far away. It gives a name. That's just a name. Now, let's look at the code for the component. The component. Oh, okay. That's a common mistake. See, I changed my file, and so I didn't save it. So when I applied my commit, it changed on the file system, but it did not update in my user interface. So I will just close this without saving and reopen it. Yeah, it's better. That's what I wanted to show you this, so it's better that we can see it, of course. So this ref object, this is an object that will track the contents of the elements that is tagged with the input string. So this input string is the same string as this one. It's just a string. You can choose what you want. Okay, and now we will wait for our component to be mounted, and then we will call the focus method on it. Okay, and then it does what we want to do. It focuses it when we refresh the page. Okay, so we're making good progress. Let's change a little bit our code base because I want to show you that a very important point actually. It's very simple, but it's important. This code is not really specific to our to-do list component. It's some generic code that you could imagine other components that they may have the same need. And so what we can do is we can move this code away and move it into. Oh, I'm sorry. I pressed enter at the here. That's what I meant to do. Okay. So what we can do now is to move this code somewhere in a different file. In this case, we have a utils file that exports a use autofocus hook that is generic. You see, it takes reference name as a string argument, and that function does not know which inputs it will target. It doesn't care. It's a generic function, and you can import that function in your component. This one, use autofocus here, and call that function in your setup method. And this is very powerful. It's simple, what I did, but it's quite a deep change. It means that now that your use autofocus is some behavior that you can import in a component. And that's quite important. If you worked with mixed scenes somewhere in the past, that's what many frameworks try to do. You have frameworks trying to do multiple inheritance or mixed scenes. They have many different ideas on how to share some behavior between multiple classes. And I think that's the React framework that popularized the hook ID first. In my opinion, as far as I know, and I think it's very interesting that they found a way to have composable mixins, and that's what hooks are. So you can see this user focus function can be imported in any component at all, and it will work. And you can create reusable behavior like that. And if you look into the web client code base of Odoo, you will see many hooks. Use model, use position, use drop down. Many of them exist because this is a very simple way to share share behavior between components. Okay, so I'm sorry I'm going fast because I want to get to the end of this. Next commit is about adding a new possibility of toggling to-dos. So let's, no, this is the 9th commit, yeah. And the feature that I'm talking about is that we want to manipulate this state. So see, it can change. So now it's those to-do items can be tracked. We can track if they're done or not. And how do we do that? There is something subtle that I want to emphasize. So let's see, yeah. So for now, we talked about props as a communication mechanism between a parent component and a child component. That's the way it works. But here, what we want to do is we want to basically communicate in the other way. We want our to-do item to notify its parents that some state has changed. Of course, we could change the state inside the to-do item itself, but it doesn't feel good because really, usually a good rule of thumb is that if some component owns some state, and that's the case for the to-do list. The to-do list manages this list of to-dos. The to-do list component is the owner of that state. So we don't really want to modify that state behind its back. We want to notify the component that its state has changed and something should be updated. And also, so that means that when you click on a to-do item, you want the to-do item to notify its parents that something happened. And how can you do that when the props are given from the parent to the child? Well, the answer to that question is we can go the other way using function props. So the idea is that the parent component gives to its child component a function, and that the child component can call that function whenever it wants to. So this is the way you can do it. You can either use a JavaScript expression. In this case, it's a lambda function, or you can use a special .bind suffix. I don't want to get into that too much, but basically we send a bound version of toggle to do method to the child component. Okay, so let's look at what it looks like in practice. We have here our to-do item, and we give to the to-do item a method. That method comes from the to-do list. Let's look into it, yeah. This is the toggle to-do method. Really, basically, it takes an ID, and it will look into its list of to-dos. Do you see, this is a list to-dos. It will look into it, find the to-do item, and then flip its state. So it's just some state change, okay? Okay, and then the to-do item, really, it needs to track the change. So we have a t-onChange directive that will call onChange method, and the onChange method will call the toggle props that it received. And see, I added here a toggle function, because if I don't do that, my props validation will crash. And so that guarantees me that this static props object is up to date. Okay? Now, let's move to the next part, which is really basically the same. It is adding another feature to remove a to-do, and it's really architecturally the same idea. We receive a remove function, we call that function. We need to modify a little bit our template to add remove a button, or in this case a span, to remove, that we can click on to remove a to-do item, and we need to implement in the to-do list some remove logic. So in this case, we will splice the to-do list, and you can see that the reactivity system can understand that if you splice a list, it means that this list has been modified, and so the user interface should be updated. So let's see. Oh, that's not what I meant to do. I meant to refresh this page. We now have a delete button here, and it works. Now we have nothing else. Oh, there's an interesting bug. And it works, okay? Where are we going to, what are we going to do? We are going now to add Okay, okay. So now next step, we want to. We don't want to generate to use just one to-do list. We want to manipulate more than one because it's more interesting to do it that way. So let's do that. And let me show you what it looks like in live. Now we're getting more structure. It looks more like a Odoo application. We have a control panel. That's just because I wanted to mimic the web client. We will add some buttons here in a moment. And we have one to-do list just here. And you see, it's alive. It's really the same component that we did. But since it's a component, it's reusable. We can add more than one to-do list. That's what next step is about. And there is some change. We have now a to-do component. That's really our application. And we have below that one to-do list. Okay? And there is not much to say about the implementation. The to-do application here contains now this to-do component. This to-do component, for now, it's some HTML where you have action. I named that action like in the web client, and you have some control panel just here. Now, let's do the more interesting step to allow dynamic updates of this list of lists. And really, let's do that. We will need to create, to have a way to create more lists. So we need a new button here. And when you click on that, you generate new lists. And all of them are separate to-do list instance. So let's look how you can do that. So obviously we will need to iterate over a list of something. So this means that this to-do component needs a list of a description of this list of lists, and this description is a list object. But maybe let's look at this in a code. Oh yeah, for now our list object is just an empty list when we start, and then whenever I add a new list, I just push a description. So I decided for now to give it an ID again. It's always useful to have an ID, unique ID, and then a name because it's nice to see what list is what it's about. So maybe later we should add a feature to rename a list, but for now I did not do it. Okay, so we have some states, some reactive state, and you can see that this use state is taking an array and not an object, and it's fine. Array and object can be used for the reactivity system. It works like you expect it. And so we have our T for each expression. We just use this T for each expression to instantiate many lists, and each of them has their own name as a prop. Okay, and we have our new list button, which is in our control panel, and when you click, we add a new list. That's the code I showed you. Okay, so we are making progress. Now, let's add multiple applications because for now it's kind of limited yet. We will add the contact application and dashboard application. Let's see what it looks like. We now have to-do application, a dashboard. It's empty, but it's there. A contact application, and our to-do application still works, of course. Okay. So, as you can see, the nav bar here now needs to change. It needs to track which state is active, and actually, it's not the nav bar that needs to do that because it's a global ID. The web client itself needs to do that. So we have I implemented that. My web client, I have a list of applications, so it's starting to get more generic. We have a list of applications. They have a technical ID, so it's useful. So it could be a number, but I just use the string. It's more descriptive. And we have a string that will be displayed. And then we have a state that tracks which is the one that is active. It's a to-do. And we have some logic to change it. And really, there is not much more to this. We give to our navbar the list of applications, so it can display all the applications, and we tell the navbar which one is the current application. And we have our callback prop select app, because when we click on an application on navbar, you want to notify the web client that it has changed. And now the web client, I will improve that in a minute. The web client has 3 if statements to say, if the current app is this one, then we have to do a component. And if this is this one, we use the dashboard component. And if it's contact, we use the contact component. Now, this does not seem very generic. Whenever you need to add a new application, you need to update this template. Doesn't go that well. So let's change this template a little bit to make it generic. And to do that, I will use the dynamic T component directive to to use a dynamic component. So this should be a component, and whenever that component change, all will properly, accordingly update the user interface, okay? And it's done. I had to change a little bit my description of an application. Now it tracks an ID, a name, and it gives you the class that it should use as a component, which component is the root component for this application. Okay, small change. And it still works, obviously. So I can do this, and it works. But now, now we have a big problem that I didn't show you before, but let's do this. I will create this. I have some state. Then let me show you something else. I have a profiler. I can just record what's going on. I will click on the dashboard. And if you see, the process of opening dashboard application destroyed the to-do component. It's destroyed now. So when I come back, we lost the state. It's a new component, and it's lost its state. That's really a big issue, because obviously, when I add some to-do, I don't want to lose my state like this. So to solve this, let me just discuss a moment how we can do that. When your component is destroyed, all of its local state is lost. So to do that, to solve that problem, we need to move the state somewhere else. And that's what we are going to do. We will move the state to a component that is not destroyed. And let me just show you very quickly. I don't want to take too much time because I'm running out of time. So this is there is an idea of an environment object that is a shared object between every component. So our web client has an environment as a env object, and all its child components have it, and so on and so on. And at some point, you can add information to that. So you see, the controller component has a sub-environment. It means that it added some information to that environment, and all these child components can use it as well. So our strategy to solve our to-do problem is that we want to move the state to the environment of the web client, and so the to-do application, to-do list, and to-do items, they can use it from that. They can take it from that. So let's do that. Okay. And let's just quickly go over the code. So this is the to-do store now. I think that's interesting to see. We have just a basic class that manages a list of to-dos, a list of lists. That's the point. It creates lists. I just moved all the to-do logic, business logic, into this class. It can create a list. It can create a new to-do inside a given list. It can toggle a to-do inside the given list, and it can remove to-do inside a given list. And now the way it works is that our web client will instantiate a new to-do store. It will make it reactive, and it will add it to the environment. And from there, every subcomponent can read that state from the environment. You see, we just read this value from the environment, and then we make it reactive, and then we can call method on that store, and it will work as you expect. So now let's check it out. I will create some state here. I have let's say two lists. Then I move to the dashboard application. Then I move back, and the state is preserved. It's still there. Now I'm not sure. Do we have how much time do you have? Can I like 5 more minutes? I don't know when we started, so I want to show you even more. But okay, let's move to the next exercise, which is adding a to-do counter. Now, the feature that I want to show you is that I can add some state here, to display some state here. And this state here is a list of to-dos. And whenever I create a new to-do, it's updated. And you have, it tracks which one are done. So you have the total amount of to-do that you need to do yet. Okay? So it's getting better. And of course, I can move away and back, and it still works. The way we can do that is simple. Now, because our state is properly located in the web client environment, so I can, in my navbar, I can simply just add some HTML, some template to just fetch the number of to-dos. So I need to modify the to-do store, and I just display those values, and it works. It will properly register the navbar as a subscriber of all the values that depends on this computation that is done somewhere here. So this will just iterate over all lists to compute the list of to-dos that are completed. Okay. Now there is a small refactoring here that I need to do. I just moved in this refactoring all the web client code in a subfolder, so it's easier to understand. And I created a new hook used to do store. So let's check what it does. This is a new hook, and that's interesting. This hook is really, it encapsulates the idea of fetching the store from the environment and making it reactive for a given component. And this hook now use another hook from all, use env, so I can get a reference to the environment. And using that hook, all of my to-do components can simply do that, and they don't care where the store is located. They just call that function, and they can use the data from that store. So that's a nice refactoring. Now, it's step 17. Okay, so next step, we're getting to the end, don't worry, is to factorize some code, some templates. If you look at this, we have a template where I have a div with a class or action, which contains a div with a control panel class, some CSS, and then we have a div with a content class, which contains something. And it is the same for our dashboard component. We have really the same structure. And if you look at the to-do app, let's look at it, we have the same structure again. We have div here, we have some control panel div here, and then some content div with additional CSS. And we want to factorize that, obviously, because we don't want to maintain the same structure for all of your application. So to do that, we need to introduce generic components using slots. So first, to explain slots, they are very powerful. Let me show you a fictional example of a fancy box component. We have a box component that takes two props, some title and some body, which are strings. And this is a template of what it could look like. We have some fancy HTML with a title and the content. It's very nice. But what if you want to add some dynamic element in your body, in the content of this? Oh, there is a mistake. I changed body to content in one of them, but not in the other. Of course, this content, it's supposed to be body, or the other way. Okay? So, the question is, how can you give dynamic content inside that fancy box? Because your fancy box may be used by many other components, and you don't know what they want to do. And let's see what we can do. In this case, on your left, you have the user of our fancy box component, and it can insert a sub-template inside our fancy box component. You see, it's not as a props like the other props, it's inside the template. Now we have to close the fancy box component below. And this content can be inserted by the template of the generic component as a slot. This is really a very, very powerful API to generate dynamic components. Now, this fancy box component can be used in many contexts to do a lot of stuff. You can just you can insert inside this component whatever you want. And just for the record, this slot API is really based on the Vue system, which has the same name, the slot system. So you can, if you know about Vue, you probably will be familiar with that. Okay, so let's do that. Let's see how we can use it to factorize our code. Yeah, it's the last commit. So okay. So it's the last commit, so I'm getting to the end. Let's look at, I created a layout component. Let's look first at how it's implemented. We have a new component. It's a generic component named layout. And if you look into the web client, that's what you will find. You will find a similarly named component. And this layout component really has only two props, some CSS class and some slots. And let's look at the template. The template is this one. We have two slots actually. We have the control panel, and you have a named slot. This is control panel. It is a slot with a name, and I will see how to use that. And then we have the content of our layout. It will be inserted here as a default slot. And we have also additional class that you can see here that will be combined with this one. So that's nice. You can have all your static class set in one place, and then you can just have the TATT class attribute to add your dynamic classes. And let's see how it's used. So let's open, for example, first the contact application. The contact application now defines the content of the control panel inside the name slot control panel. So that will be inserted at this location. It's the same for this, but we can add some content below, content for contact maybe. Okay, and same here. I have some content here. This is the default slot. Everything that is not a named slot will be the default slot. And let's look at the to-do component. The to-do component now has a button in its control panel. That's what we want. And this is the default slot, our list of lists. And let's check that it works. Okay, up. And so we have our list of lists. It works. We can move. It seems to, you see some content here. And for contact, I had content for contact. It doesn't look good, but it works. And you have, as you might expect, a child component layout in this case. And same here, of course. You have the to-do component, which contains a layout component, which contains to-do list. Okay? So, I think we made a lot of progress. We made a lot of progress in this talk. So now we have something that looks and feels like a real web client. And that's actually that's what I want to say. Can you even spot the difference? So one of them is a real web client from the master branch, and the other is what we did. And I'm not sure you can tell the difference, but I will tell you the one we did is the one on the left. So you can find all the code for this talk on my repository. You can play with it if you want, it's fine. Thank you for your attention. Okay. Okay, so I'm told that I was too long and we don't have time for a QA. Sorry about that. So